Hello everyone, welcome back, and in this lecture we are going to create our network scanning application. So in our previous sessions we have mastered pure bash watchdog, proving we can detect a single open port using the dev TCP pseudo file. Now we are taking that concept to the next level, which we will be creating our own full-scale network reconnaissance tool. Now we face here a critical constraint here. So no external binaries allowed here. Like we will not use Nmap, no ping, and even no sleep here. So scanning an entire network usually requires these specialized tools, but today we are going to force the Linux kernel to reveal its secrets. Now the core challenge here is speed. A sequential scan is too slow. Our solution is the aggressive pure bash LAN scanner. So we'll be combining parallel processing using the bash's built-in drop control, this ampersand, and wait will be used here with, of course, targeted network traffic generation. So we are not waiting for individual connections. We are launching dozens simultaneously to aggressively flood the ARP address resolution protocol cache. By the end of this lecture, you will understand how to use bash's internal functions to create a high-speed, zero-dependency host discovery tool. Now let me check that my voice is recording, and then we can start right on. Of course, we also need to arrange the display. Okay, here we are. So you can watch it in full HD. And it will just take a second here. Here we are. Yeah. Now let's get started our coding here. So we will be using user bin in environment bash. Now this is called the shebang line. Now it tells the operating system which interpreter should run this script. Now this user bin environment bash here finds the location of the bash interpreter using this environment command. Now this is preferred over using bin bash directly, because on some systems bash might not be loaded at the bin bash, which makes the script more portable, this piece of code here. And here you can see I have created new theme for this here, since most of you asked that you need to change the theme, and that is the theme. And this is going to be the pure bash based LAN scanner that uses address resolution protocol to detect devices on the local network. Now it doesn't depend on the tools like Nmap or ping, like only built-ins like the dev TCP, or which is the pseudo file of a system, the pros and net ARP. And the script here scans IP addresses concurrently and reports found devices. Now it's written also not to crash silently if something goes wrong. Now we will firstly define our default variables fastly. First we will define the default subnet, which is the first 3 octets of an IP address. So subnet, actually make it here. Yeah, subnet scan port here, or yeah, subnet should be the subnet, right? Subnet here 192.168.152. This is going to be our default subnet, which is the first 3 octets of an IP address. Basically This here means that if the subnet is already set, not empty, then keep it. Otherwise, assign the value after the colon. So you can also can add the subnet from the options page without editing this and opening and editing this shell command, right? And yeah, we will also create our default variable named scan port. It's again gonna be the scan port for default, and if it's not given any value, so here we are giving the default TCP port to attempt connections. The 22 port 22 here basically means SSH, and here we will also assign the max IP. Again, we will use the same. Max IP is going to be 254. Now this is going to be our maximum host number in the subnet to scan. So it's going to be scanning from all the way from 1 to 254. And yes, let's actually do the maximum drops variable as well. If not, if given, use the maximum drops drops here. If not value provided by the user, then we will be using let's say, yeah, 120. Now this is basically the maximum number of current connection attempts, and we will also add the pull interval. Again, we will use the same style here. If not, we will use the pull interval variable if we got any from the user, but if not, we will be using all the way 0.4. So this is basically the delay in seconds between checking address resolution protocol results. Here, let me check my voice. Yes, it's recording perfectly fine. And yes, after that we will also have verbose mode. So this is basically asking the whether or not to print extra logs, right? And this will be useful in most cases. And first we will create our helper function, which is the usage. Now this function prints help text and usage instructions and then exits. So usage here will be cat eof here. So the usage is going to be options, like most other. Here the S for subnet. So subnet is going to be what? A subnet, B subnet, or C subnet. So basically it's giving the first 3 octets. The default is subnet if not anything given. You can see here default is 192.168.1.5.2, and we will also go add the port here. Now this is the port to connect to. The default is, you can see here, 22, which is the SSH. Default is scan port. After that, we will also give the max IP. It's gonna be all the way from 1 to 254. Now we also have the default. Let's actually add. Now you can see we have a max IP 254. as well. So this is the highest host octets to scan. The default is here again is the max IP, right? G here and the jobs N, and this is the max concurrent jobs. Max jobs here. Now you can see the max job if not given the value from the user. We will set it to the default 120. And one last thing we have here is the verbose mode here. Basically, this is a verbose mode. The default is false. H here, help. In the help, we will basically show this, right? The example, let's also give the user an example how the user can run this. So 0, this is gonna be script name 192.168, for example 1, P here 22, the job here 150, and verbose mode. And after that we will end this and exit. Exit 1. So we will exit with the status code 1 after showing the usage info. And now we're gonna need to create our while loops. So here, while, of course, we need to actually do outside this usage command, the while loops, or yeah, we need to do outside this usage command. And here we will have the hashtag here do. Now this means basically the number of remaining command line arguments. While it is greater than 0, then we will just keep looping here. So okay, here we fix this. Yeah, and here while we will also use the case 1 in subnet. The hashtag if the argument is S or subnet, assign the next token to the subnet here. By the way, I will be sharing this piece of code to my blog website, theoxally.com. You can check it out from here and just get the idea. And yeah, that's basically what's going to be doing here. So if the argument is S or subnet, we will be assigning the next S token to the subnet here. So subnet equals and 2, and we will be using the shift 2. Here we are removing both the option and its argument from the list. And after that, we will be using the port. Port here. scan port. Then we are going to shift 2 here, and after that M. The M is for max IP, you know, max IP, and here max IP, shift 2, G for jobs. The max jobs is gonna be and then shift 2. In this case, the verbose will not be having any arguments. Just by using the V here, that will be meaning that user wants to enable the verbose mode. So that's basically the V has no argument. So we will be shifting by 1. And help will also not have any argument. And that's why we will be basically shifting by 1. Or yeah, let's help usage function. So when a user presses, gives the parameter as, for example, my bash.sh help or h or help like this, will be running this usage function. And after that, let's actually, yeah, we will just call the usage function and exit. And now the asterisk here matches anything else not covered above here. So we will be basically writing that unknown argument, the argument name, and usage. We will write it again, and here we are. After that, ESAC, and done. Yep. And here, see this section 3. Yep. Our code doesn't have any errors. Let's give it right now. Let's give parameters, right? Help. Here it shows the help menu. When we write, let's say verbose, it quits. When we write S, it waits for the subnet mask. That's perfect. Now thank you for watching, and in the next lecture we will continue our code. Hello everyone, welcome to another lecture, and in this part 2 of our project we will be creating our input validation to check if the provided values are valid. So we will first check the subnet format, right? So after done, we are gonna be if subnet from 0 to 9 plus backslash 9 0 again, and again 9 0 plus here, then so basically this this braces here are bash extended test braces. So this basically supports regex with this characters here. And after that, if it's not, then we will give an error. Subnet must be like 192.168.1. And we will make it 2. Now this basically redirects the output to std error. You have learned that in previous lectures. And exit with error code 2. And the if. And now we will also set the maximum IP. So maximum IP should be between 1 and 254, which is the valid IP version for host range. So if the max IP is greater than or equal to 1 and max IP is less than or equal to 254, then we will give it an error. This is basically not. So if max IP is not greater than or equal to 1 or max IP is not less than or equal to 254, then we will give it an error. And we're reading that max IP must be from 1 to 254, and we will exit with the error code 2. After that, we will give it an exit and the if. And we will also need to check the max jobs, and it should be reasonable, right? So let's say it from 1 and 2000. So if the max jobs, not max jobs 1 and max jobs less than or equal to 2000, because spaces are really important in bash, by the way, then we will also write an error saying that the max jobs must be a reasonable positive integer. And after that, we'll exit with 2 and exit 2. Fi. And that's it. So now we need to understand and write our timestamp and logging functions. So bash here provides a built-in variable called seconds. We have used that in our previous project, you remember? So the seconds automatically counts how many seconds have passed since this script has started. So we will use it to generate simple time-based timestamps, since we have very strict rules that we should not be using any external tools or anything. We will be generating our own tool, right? Which is a great way of learning bash. Seconds, we have used that in previous lectures, you remember? And again, another local variable. This is going to be ours. Seconds, 3000. In a 1 hour, there's a 3600 seconds, as you know, and we'll modulus it with 24. Spaces are again really important. Let's actually comment it out. Local minutes is going to be again let's say, yeah, another braces, and we will give it a modulus 60. it's going to be a minutes. Another, we will be using the seconds, right? The seconds will basically be s modulus 60, and this is the seconds. And after that, we will print the decimals here. And after that, we will first print the hours, then minutes, and then we will print the seconds. That's it. And yeah, that's basically it with the timestamp function. And now we will also need to generate log to print a timestamp message to a standard output. And in order to do that, we will create our log function, right? So basically, yeah, we got something wrong here. Yeah, here. Okay. And printf s new line. After that, we will get the timestamp and here we also need to create the log verbose. If the basically the log verbose prints verbose message only if verbose is true, set by the user. So basically will be if the verbose is true and printf basically the string here. And time, we will also print the time stamp. Yep. And yeah, that's it. That's it with our timestamp, log and log v functions. Now we need to run the global runtime state. So we will declare a and we will. So this basically creates an associative arrays. This is basically the map of bash or dictionary named this scene. So keys are going to be IP addresses, and the values are going to be the MAC addresses, which we will get the MAC addresses from the proc net ARP table. Now this is used to avoiding printing the same discovered device multiple times. So monitor, so we will be adding the monitor process ID. This will store the process ID of the background address resolution protocol monitor. We will create the launched 0. This is the number of scan jobs launched, and finished 0. This is the number of scan jobs completed. And after that, we will need to create our cleanup and signal handling functions. Yeah. So basically we will create our cleanup function firstly. So local rc here $. Now this basically stores the exit code of the last executed command. If the monitor process ID monitor process ID has something in it, and then so here we are basically saying that if the ARP monitor is still running, we will terminate it using the kill monitor process ID here, and we will send it to dev new. And after that, we will also wait for it to fully exit, which is this is done to avoid the zombie processes. We'll also send this to dev null. Now you can think the dev null as our garbage bag. Fi and the f. Now we will log this into exiting scanner. We'll also code it rc and launched finished. We will also print all of this, right? Finished is going to be printing as finished, and we have also discovered, right? So we will print discovered as seen. As seen. Now that's basically it. Yeah, we also need to add this. Yeah, let's end this, and yeah, that's basically it. This scene, this command here gives the number of elements, which is the discovered IPs, and after that we will exit the RC. Now that's basically it, and in the next lecture we'll continue our project. Thank you for watching, and I'm meeting you in the next lecture. Hello everyone, welcome to another lecture, and in this lecture we will be going to continue developing our network scanner tool. So we will create our monitor ARP function. ARP. Now this is a bash function definition. The name monitor ARP is the identifier used to call the block we will write here. Now we will loop forever until killed by this parent process. We will use built-in sleep if available. So while true do here is the classic infinite loop in the shell scripts. Now true is the command that returns the exit status 0, which is the success unconditionally. Now while here run its body repeatedly as long as the command returns exit status 0. Now what we will do here is basically while ifs read here, then we will line and do. Now the IFS here sets the shell's internal field separator to empty for the read command. And now this prevents the leading, trailing white space from being trimmed and avoids word splitting. And now, for example, it temporarily overrides the default IFS, which is usually space, time, tab, and new line. So the read R line here reads one complete line from the std input into the variable line. Now the R flag disables \escape processing, so the backslashes are read literally. And while do here redirects the file into the loops std input, causing read to consume lives from the file until the EOF. And after that we will need to do our red line here. Oops, not like this. Line, and after that we will continue. Now this is basically the skip header line that starts with the IP address or empty lines. Now this Z here returns true if the starting string length is 0, and if the line is empty, continue here jumps to the next iteration of the inner while loop. And here after that we will basically do the next step, which is opening a read RHW type flags mac mask def here, and we will feed it into this and true. And here we are. And after that we will skip the header line, so which is the IP address. So basically we will write the IP here and continue. Zero. And we will only monitor hosts in our current subnet. And in order to do that, we will just do the same thing again. Equals the subnet, which would be defined by the user. If not, it will set the default subnet. The nested ifs are not recommended here in this case, but we have a limited ability on this case here, since the bash here is actually not intended for this kind of projects, more like a system administration, but from just developing this project you will learn so much. Yep. And then here now only we are telling that only consider entries whose MAC field is non-empty and not all zeros. So this Nmap returns true if the MAC here has non-zero length, and this piece of code here ensures that we ignore placeholder 0 max. And then by the way, some kernel address resolution protocol entries may contain a 0 MAC, meaning not yet resolved. And after that we will print only once per IP. Now the associated array scene packets and tracks IPs we have printed to avoid duplicates. Now in order to do that we will be doing if the 0 is scene IP here, and that's it. Then, and here we will be recording that we have seen this IP and mapping it to the observed MAC address. MAC, and we will print the discovery line after this and print. So basically we'll be printing the discover the host, the MAC here, and input file, yeah, print f, yeah, string, discover host s MAC, again s, if here is s with new line. And we will add first the timestamp. Yep. Yeah, we need to add the timestamp here. After that, we will be adding the IP to show at the host's place. We will be also adding the MAC and dev. And yeah, one by one, we will end this ifs. And after that, here. And at the end of the while loop, we will first done, and we will write this to proc net ARP. This is the input source for inner loop. And after that, we will wait before checking again. So sleep pool interval, right? Sleep pool interval. Now, basically, the pool interval here defines the frequency. So this is a variable containing a number, like previously we have defined here 0.4. This is the seconds. Now the sleep here is built-in. We'll pause the script for approximately that duration. Now if the system's sleep doesn't support fractional seconds, it will typically round up to the nearest second, which reduces responsiveness but actually remains safe. And after that, we will be done. Yeah, we got... Yeah, that's the problem here, yeah. And yeah, that's it with our project. Thank you for watching, and I'm waiting you in next lecture. Hello everyone, welcome to another lecture, and in this lecture we will be continuing to developing our bash oriented network scanner. Now after doing sleep done, we will be starting the monitor in the background. So monitor ARP and monitor process ID is basically this here. So monitor ARP and monitor process ID, this actually runs the function monitor ARP here in the background with this. Now this trailing operator tells the shell to start the previous command as a background job, and this is a special shell variable that expands to the process ID of the most recently executed background pipeline. Now by assigning the monitor process ID, we capture that process ID so we can later kill or wait for it. Storing it allows clean shutdown in the cleanup trap. So basically we will be doing the log started ARP monitor process ID, monitor process ID, subnet here, 0. Yeah, it's actually going to be the subnet 024 port, scan port also, and we need to add the concurrency 2, which is going to be the max jobs, right? Scan port concurrency and max jobs. And basically after that, we will check that if the variables is true, then the log v prints additional info. So the variables and log v function we have created earlier will print that variables mode enabled. And if the variables expands to false, empty or false, the right side in this case is going to be skipped. So then we will create our scanner worker. So basically what we'll do here is scan once bg here. So this function here will attempt a pure bash TCP connection to the given IP and port by using this dev TCP pseudo device and the file descriptor redirection. So the primary goal here is to force the kernel to perform an address resolution protocol request for the IP, which will populate proc net ARP if the host response. Now the function is intentionally small and minimal in this case. It takes the connection attempt and then immediately closes the file descriptor if successful, and failures are normal. If the host does not respond or the port is closed, the exec operation will fail and return to non-zero, because we run this inside the subshell that is background. So that failure does not kill the main script, which is good. So after, variables mode enabled, that's it. And here we are, open the braces. Local target IP is going to be our first. Local port is going to be 2. And we will start the subshell wrapped in this parenthesis and the backgrounded with the ampersand, this character. Now this subshell ensures any non-zero exit from an exec or other commands inside it does not trigger error exit behavior in the parent, like the whole script, and localizes file descriptor usage. So what we will do here, if the exec here, this is the file descriptor dev TCP, we will set the target IP / port and then dev null, and then exec here. This line of code here closes the file descriptor tree for writing and reading. Now we intentionally do not attempt reads writes that could block, because the read write might hang if the remote side expects protocol bytes. So the minimal open close strategy is enough to trigger address resolution protocol in most kernels. And yes, that's basically done. And we will end the if here, and we will add this trailing character background, which backgrounds the entire subshell. Now because the subshell was backgrounded, the shell will immediately continue, and after that we will basically printf the D here and yep, that is it. And here this is returning to the background shell's process ID for bookkeeping. Now this line of code expands to the process ID of the most recently backgrounded command, and this printf d here prints that the process ID as a decimal integer without adding a new line, and this lets the caller capture the process ID if the desired. Hello everyone, welcome to the last lecture of our section. In this lecture we will finalize our project and run it. So we have few functions to develop here. The first is running jobs count. Now this function's job is to count how many background jobs are currently active. Now this allows the script to enforce concurrency limit, ensuring we never exceed this max jobs simultaneous TCP attempts. The implementation is going to be like something jobs.p, which outputs only the process IDs of all active background jobs. So local AG here, this is a local variable. This is an array G to hold the job process IDs. Map file TG here, jobs P. Now this reads the process IDs of all active background jobs into array, and map file TG. This line of code here basically means run jobs P in a subshell, capture its output line by line, and fill array G, one process ID per element. And after that we will print echo, which is the number of active background jobs. G here and add. That's it. And now we also need to develop the show progress function. Show progress. The purpose of this function is to update a single line progress indicator in the terminal, and it also displays how many connection attempts have been launched, how many finished, and how many discovered so far. And here this basic, let's actually comment some information here. The one here is total number of IPs to test. The 2 here is number of jobs launched so far. The 3 is gonna be the number of jobs finished so far, and the 4 is going to be the number of discovered hosts in ARP table. So local here, total local launched, local finished, and local discovered. And now we will need to print the formatted progress line. With printf are here launched D, here finished is again D, discovered D, and remaining to launch is D. And here we will give it a timestamp launched, no, launched, finished. Also, we'll need to do the discovered and the total here. Now, this is remaining to launch basically. So we will be subtracting the total from the launch from the total. And yes, that's it. This function is also done. And now we will need to create our function and name it the launch connection attempts. No, not actually, we don't need the launch for this. So here in this line of code, I will iterate over all IPs in the target subnet and launch lightweight TCP connection attempts on the target port. So yeah, also we need to timestamp launch discovered. Yeah, after discovered, we need to add this. Yeah, no need to. Okay. So for only one, while I is less than max IP, increment I by 1, do. And here we will construct the target IP. And we will launch a background TCP connect attempt. Process ID. Yeah, we also need. Yep. The process ID here, the scan wants background and target scan port. Now the scan once background function handles the dev TCP logic, and if the function fails, which is pretty rare, the fallback is going to be the process ID 0. And we will also increment the count of launch jobs by 1 plus 1. And if the verbose mode is enabled, we will print which host is being tested. Launch connect to target here, process ID. Yeah, process ID here, and we will get the process ID variable here. And we will also show current progress after each launch. Show progress here, the max IP launched, finished, and seen. Of course, we need to add the hashtag before seen, and since this is a process. And yes, now we will need to concurrent the control loop, and in order to do that, yeah, we will do the on the same line. So while true, 2, 3, 4. Okay, I found that while true. So the purpose of this line of code prevents spawning too many simultaneous jobs. So if the number of running background processes equals or exceeds the maximum jobs, the loop should wait, right? So while true, do check how many background jobs are currently active by this command running as, since we are actively logging the running jobs on the count, running jobs count. Okay, yep. And below that, if we are below concurrency limit, proceed launching new ones. If running is less than max jobs, then break and enter if, and otherwise wait for at least one job to finish before continuing. So, and this wait and here, which included in bash 4.3 and upper, waits for any background job to complete. Now, if it's available, we use it to effectively block until one ends, and if not available, if the, for example, user uses older bash versions, we fall back to short sleep, right? So wait n2 here, the null, and then finished +1, since one job is done, and we will also show progress. Give it the max IP, the launched, finished, and this scene. Not, instead of using IP, we will add this ampersand here, and yep, we will also need to add this hashtag. That's it. And else will fallback behavior for systems without this n, you know, sleep 0.05. This is a short pause, avoids CPU spinning while checking. Fi done. And now after that, we have come to our final code. We will be waiting for all the background let's check this code pretty quick, and here we are. Port subnet port is 21. Yep. And yeah, let's finalize for this project. We will here in this code that we will wait for all background jobs to finish. The purpose of this code, after all connections attempts are launched, we will ensure that every background connection has completed before summary. So we'll create log, another log. We'll say that all launched attempts launched, waiting for background connect processes to finish. And after that, we will keep waiting until there are no running background jobs left. While true, do here running the running drops count we had there, and if the running here equals to 0, then break. And if here again, and we will again prefer to wait this n here, wait n. Yeah, we will use the same piece of code. I will just copy from there to make it quicker. Finish +1 for show progress seen. Yeah, this is basically the same code, and after that we are done. And now after that we need to do our post scan delay and summary output. So we will give a kernel a short moment to flash ARP updates before reading this proc net ARP one last time. So we will sleep for half a second. This is a brief grace period, typically enough for ARP address resolution protocol cache update. And after that we will print the final line break, so progress line doesn't override next log line. Log the scan finished, launched here, finished, oops, so we actually finished, and this word is here at scene, right? Scene at. And if any hosts were found, we will list their IPs and MAC addresses neatly. Scene. Yep. And after that we will log that it is covered hosts for IP in scene. We'll print the printf to make sure it's nice and clean. New line. The first we're gonna print the IP address, and then we will print the scene. And yep. And after that, that's done, right? The last lines of our course, of our program. So else log here no host discovered in prognet ARP for this subnet. (024) and the if, and exit the script with no error. That's it. We have reached here. When we reach here, this basically means all background drops are complete here. The monitor ARP process will be terminated automatically, and by the exit trap calling to clean up. Now that's it. With our tool here, we are done. Thank you for watching, and I'm waiting you in next lecture.